Can we predict the mortality of a person? Sounds like God, no? Is it possible? Seems interesting. Hello friends, this is Swapnil Shrivastava from ABS EC. In this video, we are going to present a project that we have done in internship under the Bennett University. It is an initiative by Leadingindia.ai. We have worked in the project in which we have given the dataset of approx 80,000 patients with 342 attributes, in which we have to predict the mortality of a patient when he is admitted to the hospital. In this, we had been given supervised imbalance data, as death rate of patients were very less as compared to the alive rate or alive patient. In this project, we are interested in predicting the mortality rate of person who is admitted to the hospital. In a single day, just a single day, hospital receives tons of data of patients. We are trying to utilize that data for making a model which can truly predict the mortality. Now, let's talk about the technical aspect of our project. And for that, my friend Naushad will carry forward. Thank you.
Hi, my name is Naushad and I am from MIT Jammu. I am going to discuss about the dataset that we had. The dataset contains the records of around 80,000 patients and it has 340 different time varying features. The data was labeled, that is, we had been given that if the patient would die or not, and we had to predict the results for the test data. But there was a problem in the dataset that it was imbalanced, with the dead patients comprising only 3% of all the 80,000 patients that we had. If now trained directly, this would confuse the model. So there was a need to remove this imbalance in the data set. So we used different undersampling and oversampling techniques. We tried and tested them and saw which would be better. Now we also removed some columns that didn't play any role in determining the mortality of the patients. Now there were some columns that were textual in nature, so there was a need to encode them somehow. So we applied label encoding to columns like gender and ICU. Now there were also some missing values in the data set, and we filled them by the mean of the data in their respective columns. Now to test the accuracy of the model, we split the training set into training set and validation set, with the validation set being 25% of the training set. We use validation data to determine the accuracy of different models that we used. Now to explain about the models that we used, my teammate Bhavya will come and explain about that.
Hi, I'm Bhavya from Ambedkar Institute of Technology, and I'm going to explain all the models that we have used for this particular problem. So the number one model is neural network that we have used to predict the mortality of the patients. So neural networks are basically their parallel and distributed information processing systems, and they are inspired from biological learning systems such as human brains. And the accuracy that we get from this model is 68.7%. Second model that we used is gradient boosting. So it's a machine learning technique for classification and regression, and the accuracy that we get is 72%. Now the third model is random forest, and it consists of multiple random decision trees, and this model gives us the accuracy of again 72%. The fourth model is logistic regression, and it's a binary classifier algorithm, and accuracy we are getting from this is 73.4. The last model that we have used for this problem is the most applicable technique, which is Linear SVM, support vector classifier, and what it does, it basically fits the data and returns the best fit hyperplane which divides or categorizes the data. And the accuracy that we get from this is 74%, which is the best among all the models that we have used. We have used other deep learning techniques also, but these 5 models proved to be the best. Now, to conclude this topic, our team member Savdev will carry forward.
Hi, myself Ansari Sabda. I am from Indira Gandhi College of Engineering, Navi Mumbai. I am here to give the conclusion of our project. We have predicted the mortality of the patients during the ICU stay. In this, we tried and tested different machine learning methods. We also used some deep learning methods, but SVM, which is a machine learning model, happened to perform the best on it. We ranked 10 on the challenge leaderboard, so we can say that SVM along with other machine learning models give good results in predicting the mortality. Mortality prediction is certainly a very useful technique and it can help us save many lives or help in better treatment. An accuracy of 74 is a good result. It can at least help us an additional tool for the doctors to check their treatment. This model can further be improved using some advanced ensembling techniques.